Hey guys, today what we're going to be looking at is exponent properties. So the first thing what we want to do is look at the rules of multiplication. Anytime I am multiplying exponents, multiplying bases with the same bases with different exponents, what we're going to end up doing is just adding the exponents. So for instance, if I have x to the third times x to the second, this is going to look like x to the fifth. The reason why is x to the third can be written as x times x times x, and x to the second can be written as x times x. This would simplify to x to the fifth power. That's the first rule. The second rule, what we're going to do is look at division. If I have x to the fifth all over x to the second, I would subtract these exponents and I would be left with x to the third. The reason why is if I had x to the fifth, that would be x times x times x times x times x all over x times x. These would reduce, these would cross cancel, they would cross out I should say, and that would be left with x to the third. Okay, so now let's go ahead and jump in and look at some of these examples. Here what we're going to do is we're going to have several different types of problems, and what we're going to do is we're going to reduce these. Now I can only reduce variables that have the same base. So if I were to look at just the p's, that's a division problem. So I have 10 p's on top, 3 p's on the bottom. I have more on the numerator than the denominator. So if I were to subtract these, I would have p to the 7th left on the numerator. Now I'm going to look at my second variable, which is the r's. I have r to the 10th power on the top and r to the 20th power on the bottom. I have more left on the denominator than the numerator. Therefore, when I subtract these, I'm going to have 10 left over on the bottom because 20 minus 10 is 10. I want you guys to realize when you're subtracting these, the final answer is always going to be where there is more. So on the top, there is more p's on the numerator than the denominator, so p to the 7th was on top, where r to the 20th, there was more on the bottom, so when I simplified r to the 20th and r to the 10th, I have more left over on the denominator. So now what we're going to be looking at is multiplication. Remember, what I told you before is we can only combine variables that are the same base. So what this is saying is I have a to the 13th times a to the 3rd. If I were to combine these, I would have a total of a to the 16th power. Now I'm going to look at my second variable, which is b to the 5th and b to the 20th. If I can combine those, I would have b to the 25th, and I did that just by adding the exponents. Remember, you can only add the exponents when you are multiplying them. So now this looks a little different because I have 2xy to the second and I have 4x to the second times y. So I have a number attached there. What I want you guys to realize is I'm going to treat the numbers just like regular old numbers. And so they have their own rules, while the x's with exponents and the y's with exponents have their own rules. So you don't need to do this next step, but you could rewrite it in this order of 2 times 4 times x to the second times y to the second times y. So now, if I just gave you 2 times 4, kids get confused and say, hey, do I add those together to get 6? No, we don't. We're still going to multiply them. So 2 times 4 is 8. And then now we go to the exponent rules. This x doesn't have an exponent that's visible. It's invisible, and there's an imaginary 1 right there. So x to the first power times x to the second power is going to give me x to the third power. And finally, we're going to do the same. This y has an invisible 1 right here. And y to the second times y is just going to be y to the third as well. And this is my final answer here. Okay, so let's go ahead and do this. I'm not going to take the time to write them out, but we're just going to do one step at a time. I have -4 times -6. A negative times a negative is a positive, and 4 times 6 is 24. Then we're going to do is x squared times x squared. That'll give me x to the 4th power. I added those exponents together. my next step is I have t to the third and t to the first power. That means I have t to the fourth. So I've used my 4, I used the x's, I used the t, I used this 6, I used this x, I used this t. The only thing I have left over now is r to the 5th power. I have nothing to combine that with, so I just write r to the 5th power. Alright, so now let's go ahead and look at these. I'm going to start by looking at the 5s. I have 5 to the 4th power and 5 to the 3rd power. What this is saying is I have 5 times 5 times 5 times 5 on the numerator, and I have 5 times 5 times 5 on the denominator. Now, if I look at the a's, it says I have a times a times a times a, all over a, and then I also have b times b, all over b times b. I don't expect you to write this out, but I want you to have a visual of what this looks like. So if I were to divide these, 5 divided by 5 cancel, 5 divided by 5 cancel, so on and so forth. Then these a's cancel, and then I have these b's cancel, and these b's cancel. That means I'm only left on the numerator with 5a to the 3rd power. And if you look at this, if I have 5 to the 4th all over 5 to the 3rd and I minus 4 over 3, that would give me 5 to the 1st power, which is just 5. A to the 4th all over a to the 1st, 4 minus 1 is 3. And then b to the 2nd over b to the 2nd just cancel out, so they're gone. Okay? Alright, so now let's go ahead and look at this one. This seems to have a lot more stuff, but remember, this is just multiplication. So I'm going to multiply this straight across first, and this is going to give me 4 squared times x to the 2nd power, y to the 4th power, times x. And on the bottom, it's going to give me 2y x to the 2nd power. And here, I'm just going to start cleaning things up on the numerator first. This is going to give me 16 x to the 3rd, y to the 4th. I got x to the 3rd by looking at this x squared and this x. And that's going to give me then 2x squared y. Now I'm just going to treat numbers like numbers. So what do I mean by that? I have 16 divided by 2. I don't subtract these because they're just numbers. They're not exponents. So 16 divided by 2 is 8. I have x to the 3rd power on the numerator, x to the 2nd power on my denominator. I'm going to subtract those. I'm going to put x on the numerator because I have more 3 is a higher exponent than 2. And lastly, I'm going to have y to the 4th all over y. I'm going to subtract those to have y to the 3rd power. Alright guys, I hope these properties help. If you have any questions, please let me know.